Uh, in exercise one, we're talking about motion and muscle by our previous knowledge from anatomy and biomechanics. And in exercise two, we're going to introduce EMG setting, like in how we record muscle activity in laboratory. So EMG is an abbreviation of electromyography, and it's capturing the muscle activity, the electrical activity in your muscle, and so that helps us to understand how the muscle works, and also to verify, like in the table in exercise one, we can verify if you're thinking in the right way. So this is a setting in like describing exercise two that we got a man sitting on a chair and he initially have his knee extended, fully extended at 90 degree. And then we're going to apply a force to his ankle, a downward force, until his knee is straight, vertical to the ground at 0 degree. And during that movement or during that task, the knee angle, the EMG for quadricep, and EMG for hamstring is recorded and presented in your manual. So we can take a closer look at what does that mean. So for knee angle, we can see it's initially like 90 something degree and then decreases. So we know if the knee angle decreases, that means it's knee flexion, right? So it's doing a knee flexion task. And we put a electrode on either quadricep and hamstring, and we can see the raw signal of EMG. So like this, you can see it's really different from baseline, right? The amplitude is higher and all of the noise. So that's a raw signal. If we want to analyze it in a laboratory setting, we're going to do some post-processing. But by seeing the raw signal, we're able to identify if the muscle is activated. So you can see the amplitude of quadricep is pretty high, right? And the amplitude for hamstring is comparing to quadricep, is pretty small. So we can explain the task by these three graphs. By the knee angle, we know is knee flexion, right? And for EMG on quadricep, we know when it starts to flex, the quadricep is turned on. But hamstring relatively is not that much activated. So quadricep is on, hamstring is off, and it's doing a knee flexion. So you can think about what kind of action is it? Is it concentric contraction or eccentric contraction? The knee is flexing and the quadricep is turned on, so we know it's eccentric contraction of quadricep. And because we're applying a force to the ankle, and if the quadricep is not turned on, the ankle will be slammed to the ground. But we want to avoid it. We want to slow down. We want to apply a braking force from our quadricep. So that's what the people is doing in this kind of setting, and we're able to tell the details by these three graphs. Yeah, that's easy, right? And that's everything for exercise 2. I hope the background information can help you answer all three questions. And that's a pretty short video. We're going to talk about exercise 3 in the next video. Okay.